Mr. Paka.
Sir, Karunakar sir.
Sir.
Live class.
Only going to screen sharing.
తీసేసాను నేనే ఉండనా
పెట్టండి
స్టార్ట్ చేద్దామా
సార్ మీరు స్క్రీన్ షేర్ చేసుకొని ప్రాబ్లం ఓకే
స్టార్ట్ చేయండి
షేర్ అయింది సార్
సరే సార్
ఓకే సార్
ఓకే రైట్ థ్యాంక్ యూ అశోక్ సార్ థ్యాంక్ యూ రమేష్ సార్
సార్ మిమ్మల్ని హోస్ట్ చేస్తున్నాం ఇంతసేపు కోస్తున్నారు
ఓకే ఓకే
మిమ్మల్ని హోస్ట్ చేసి మేము లీవ్ అవుతాం సార్
రైట్ రైట్ ఓకే థ్యాంక్ యూ
ఓకే సార్ థ్యాంక్ యూ ఫర్ యువర్ కన్సర్న్ సార్ టువర్డ్స్ ద స్టూడెంట్స్
Okay.
I hope this session also students will enjoy and get benefited from you, sir.
Thank you, thank you.
Thank you, sir. Thank you very much, sir. On behalf of Hanmakonda and also on behalf of the students. Okay, sir. Please continue, sir.
Right, right, Ashok. Thank you, Ashok, sir. Thank you for giving this opportunity. So, to interact with the students regarding PG entrance. So, good morning, dear students, once again.
Morning, sir.
Okay, today's topic is phase equilibria. So, you might have studied as phase rule. మనకు తెలుగులో ప్రావస్థానీయం అని చదువుకుంటాము. Phase equilibria. So this phase rule can be understood for equilibrium processes or equilibrium systems. This rule is an important tool used for the quantitative treatment of systems in equilibrium. Quantitative treatment of systems in equilibrium. And it predicts the conditions that specified for a system to exhibit equilibrium. It predicts the conditions that specified for a system to exhibit equilibrium. Now, initially, scientist Gibbs gave the phase rule for investigating heterogeneous equilibria. So the phase rule for systems in complete internal equilibrium. So this phase rule, so mathematically we can write as F equal to C minus P plus 2. So this is a familiar equation. Whenever we read a phase rule, so we come across F equal to C minus P plus 2. And here, you know, number of C is the number of components and P is the number of phases. And F is the number of degrees of freedom. Now let us see one by one the terms phase, components and degrees of freedom. So what actually phase is? It's any homogeneous and physically distinct part of a system. So which is bounded by a surface and is mechanically separable from the other parts of the system. Suppose, take this example, the solid calcium carbonate is in equilibrium with the calcium oxide and carbon dioxide gas. two solid phases and one gaseous phase are the phases for this equation. So the both are solids, but they are considered as two solid phases because two different components, hence they are two heterogeneous. So two solid phases, one gaseous phase. And the next one is components. The smallest number of independently variable constituents. The composition of each phase can be expressed in terms of chemical equilibrium. Sorry, chemical equation. Smallest number of independently variable constants. The components of each phase can be expressed in terms of chemical equation. Okay, is it clear for all of you, dear students?
Repeat once again, sir.
Okay. Is it clear my voice? Is it audible?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Good, good. The smallest number of independently variable constants. The composition of each phase can be expressed in terms of chemical equation. Whether the atom or molecule in which is in equilibrium from one phase to another phase. Look at this example. So water exists in three phases: solid ice, liquid water, and water vapor. If these three phases are in equilibrium, but in all these phases, the water H2O composition, chemical composition is H2O only. The composition in each phase is H2O only. So hence, this equilibrium in different phases, it is a one component system. It is considered as one component system. Because వాటర్ అలాగే ఉంది కాబట్టి దాని యొక్క కాంపోజిషన్ ఎలా ఏ విధంగా కూడా మారలేదు in all these phases, on the three phases. Hence, it is a one component system. So let us see the degrees of freedom. What is meant by degrees of freedom? It is the number of independent variables. What are that variables? Temperature, pressure, and concentration. అంటే ఈ మూడింటిని బట్టి మనకు ఇది ఏదైనా సబ్స్టాన్స్ లేదా ఏదైనా కాంపౌండ్ యొక్క కాంపోజిషన్ అనేది చెప్పవచ్చు. ఇది టెంపరేచర్, ప్రెషర్ అండ్ కాన్సంట్రేషన్. So which must be specified in order to define the system completely. So for example, state of a gas can be explained by the variables pressure and temperature or pressure and volume. So కాబట్టి వీటిని ఏమంటాము? డిగ్రీస్ ఆఫ్ ఫ్రీడమ్. వీటిని డిగ్రీస్ ఆఫ్ ఫ్రీడమ్ అంటాం మనము. సో విచ్ ఆర్ వేరియబుల్స్, ఇండిపెండెంట్ వేరియబుల్స్. టెంపరేచర్, ప్రెషర్, కాన్సంట్రేషన్ ఆర్ కాంపోజిషన్. ఇప్పుడు మనం గ్యాస్ యొక్క ఏదైనా గ్యాస్ యొక్క దాని యొక్క స్టేట్ చెప్పాలంటే వేరియబుల్స్ వేటిని బట్టి చెప్పవచ్చు? ప్రెషర్ అండ్ టెంపరేచర్ ఆర్ ప్రెషర్ అండ్ వాల్యూమ్. Okay, now. So, kabatti gas can has 2 degrees of freedom, either pressure and temperature or pressure and volume. Suppose H2O liquid, which is in equilibrium with water vapor. So both are in a same composition, that is H2O, H2O. So it is one component system. And it has 1 degree of freedom. Induku 1 degree of freedom? The known temperature, then pressure automatically specified. Okay, na? Pressure, known temperature, at known temperature, the pressure has to be specified. So that's why it is monovariant. It's a monovariant system. Liquid and water, liquid water and water vapor, which are in equilibrium. It's a monovariant system, and it's a one component system. Now take this water, that is ice, liquid, and vapor are in equilibrium. The 3 phases are in equilibrium. So these 3 phases coexist only at one particular temperature. So when you change the temperature, these will not exist. So these 3 phases will not exist. So hence it has no degrees of freedom. So at this condition, it is invariant. So if F equal to 0, that is no degrees of freedom, it is called invariant. If number of degrees of freedom is 1, it is univariant. If number of degrees of freedom is 2, it is bivariant. If number of degrees of freedom is 3, it is trivariant. So the minimum number of phases in any system is 1. మనకు ఏదైనా సిస్టంలో మినిమం ఫేజెస్ ఎన్ని ఉండవచ్చును? 1 ఉండొచ్చు. సో అకార్డింగ్ టు ఫేజ్ రూల్, F equal to C minus P plus 2. ఇక్కడ కాంపోనెంట్ వన్ కాంపోనెంట్ సిస్టమ్ కాబట్టి C equal to 1. The minimum number of phases should be 1. So 1 minus 1 plus 2. F equal to 2. So what is F? Degrees of freedom. So the one component system is bivariant. Okay, one component system is bivariant. The 2 variables are temperature and pressure. Suppose if that one component system has two phases, which are in contact with each other, H2O liquid and H2O gas. So again, from this equation, F equal to C minus P plus 2. C equal to 1, phases are 2 plus 2. So the degrees of freedom is 1. Degrees of freedom is 1. Hence, it is a monovariant. It depends on temperature or pressure. Now, to here, what we discussed, the Gibbs phase rule, the terms which involves in the Gibbs phase rule, and there are some examples for degrees of freedom. The diagram కనబడుతుందమ్మా క్లియర్ గా ఉందా కొంతనా is it visible?
Yes, sir.
Yes, sir.
Yes, sir.
Now this graph represents the phase diagram of water system. Which system? Water system. These curves represents or gives relation between pressure and temperature. And this point O is a triple point. Okay. OA represents vapor pressure curve. And OB represents sublimation curve. OC represents fusion curve. So this triple point, 4.58 millimeters of mercury. And the temperature is 0.0075. The temperature and pressure values of triple point. And from this graph, from this diagram, liquid and vapor are in equilibrium. Liquid and vapor are in equilibrium. And the solid vapor are in equilibrium. That is sublimation. And the solid liquid are in equilibrium. That is fusion. So OA represents equilibrium between liquid water and vapor. Now for this curve, since there are two phases, so F equal to C minus P plus 2. So C is one component. Water is one component in any phase. and the phases are 2. Hence, 1 minus 2 plus 2 equal to 1. It is univariant. What is that? Univariant. Then OB represents the equilibrium between ice and vapor. It is called the vapor pressure curve of ice. It also has degrees of freedom 1. Univariant. So for each temperature, one and only one pressure. For each pressure, only one temperature will observe for the equilibriums. And as I said, the point O, which is a triple point, O and OB meet. OA and OB meets. Here, 3 phases coexist. It is known as triple point of water. And the temperature 0.0075 degrees Celsius. Pressure is 4.58 millimeters of mercury. Now at triple point, the degrees of freedom. Since it is one component, 3 degrees, 3 phases coexist, plus 2. 1 minus 3 plus 2 equal to 0. It is invariant. The degrees of freedom are 0. In another curve, OC represents the equilibrium between ice and water. It is called the fusion curve of ice. It shows the effect of pressure on melting point of ice. So this is a fusion curve. It shows the effect of pressure on melting point of ice. The melting point of ice is lowered by increase of pressure. What? Component system, that is water system. The phase diagram is water system. Next, let us see the two component system. For a two component system, the phase rule F equal to 2 minus P plus 2. F equal to 4 minus P. And for any system, the minimum number of phases should be 1. So 4 minus 1. So F equal to 3. So the 3 variables are difficult to draw a graph Hence, one variable kept constant. The మూడు వేరియబుల్స్ ను 2-dimensional గ్రాఫ్ డ్రా చేయలేము. So, కాబట్టి one variable should be kept constant. The phase rule equation becomes F equal to C minus P plus 1. Instead of 2, we have to consider as 1. So this equation is called reduced phase rule. ఓకేనా? ఎలా వచ్చింది? F equal to C minus P plus 1. అంటే మూడు వేరియబుల్స్ ను ఒకేసారి చూపించలేం కాబట్టి ఏదైనా ఒకదాన్ని కాన్స్టెంట్ గా ఉంచుతాం. కాబట్టి దిస్ ఇస్ రెడ్యూస్డ్ phase rule. For the two component solid liquid equilibrium, so we have the two components are miscible in the liquid state and the two components are partially miscible in the liquid state. The two మనము study చేస్తాం. Are miscible in the liquid state. The two components are partially miscible in liquid state. First category, we have again two different categories, A, B, C. The two components are not miscible in the solid state and form a eutectic mixture. The two components are miscible in the liquid state. Again, it is a category, that is, the two components are not miscible in the solid state and forms a eutectic mixture. So the two components form a stable compound with a congruent melting point. Third category is the two components form a compound with incongruent melting point. Three categories. Let us see the categories. The simple eutectic systems. Again, for this three component system, F equal to C minus P plus 1, since one variable should be kept constant, so we can apply the reduced phase rule. And the graph between temperature and composition, pressure kept constant. So from this graph, from this phase diagram of two component system, so generally A and B, so which are melting points of A and B. On increasing the quantities of B, the freezing point of A falls along AC. B యొక్క కాంపోజిషన్ పెంచుతూ పోతే దీని యొక్క ఫ్రీజింగ్ పాయింట్ అనేది ఇలా తగ్గుతుంది. along the AC. On increasing the quantities of A are added to B, the freezing point of B falls along BC. ఏం లేదు అక్కడ ఏబి కాంపోజిషన్ మారితే ఫ్రీజింగ్ పాయింట్ ఎలా మారుతుంది అనేది గ్రాఫ్ ద్వారా చెప్పొచ్చు. Now along AC, solid A is in equilibrium with solution B in A. So this one, solid A is in equilibrium with solution B in A. This one, solid A plus solution. Okay, let us continue. Along AC, okay, that is already we covered. AC is called freezing point curve of A. ఈ కర్వ్ ఏమంటాము freezing point of A. And along BC, solid B is in equilibrium with the solution of A in B. And the BC curve is called freezing point curve of B. This one. Freezing point curve of B. So the number of edges along AC and BC is 2 only. Since the system is taken at constant pressure, we apply the reduced phase rule. F equal to C minus P plus 1. So two components, phases are 2. Hence, F equal to will get a 1 value. It is monovariant. At point C, solids A and B are in equilibrium with the liquid phase. Hence, these are three phases. So F equal 2 minus 3 plus 1. So we'll get F equal to 0, invariant at point C. Similar to the triple point of water, where F equal to 0, which is an invariable point. And that C is the lowest temperature at which liquid is in equilibrium with the solids A and B. It is called a eutectic point. So what it is called? Eutectic point. The area above AC and BC, two components present as homogeneous liquids in the solution. For phase 1, it is bivariant. Two minus 1 plus 1. So F equal to 2. Now let us discuss lead silver system. Now try to concentrate all these points in phase equilibria, phase rule. This one, lead silver system. Now these two metals are completely miscible in liquid state. And they do not. Yes, anything you want to ask? Okay, ఈ రెండు మెటల్స్ ఒకదానితో ఒకటి మిసిబుల్ అవుతాయి, but they do not give any compound. Physically they miscible with each other. Chemically they cannot react, they cannot form a compound. So for this system, as we explained earlier, the similar graph we can draw the phase diagram. Temperature versus composition. This point A, point B. The melting point of lead, and this is the melting point of silver. Here the composition of 100% of lead, here 100% of silver. Addition of silver lowers its melting point along AC. The silver యాడ్ చేస్తూ పోతుంటే దాని యొక్క మెల్టింగ్ పాయింట్ తగ్గుతుంది. AC is the freezing point curve of lead. It containing various amounts of silver. And pure silver melts at 961 degrees Celsius. Addition of lead lowers its melting point along the BC curve. The BC curve is the freezing point curve of silver. Along AC, solid lead and solution coexist. Solid lead and a solution of silver and lead coexist. And along BC, solid lead, solid silver and solution exists. Okay. Now applying the Gibbs phase rule along AC at constant pressure, F equal to C minus P plus 1. Since these are two components, two phases, so by substituting, we'll get a F equal to 1, which is a monovariant. Along BC also, we'll get monovariant, similar to this one. The C is called eutectic point. So 2.67% of silver, the remaining is lead. The composition of a composition eutectic point. At eutectic point, the three phases, that is solid lead, solid silver, and liquid solution coexist. The temperature of for this system, the eutectic mixture is 303 degrees Celsius. The composition is 2.6% of silver. So let us practice once again for these systems which are in equilibrium. Determination of components, phases, and degrees of freedom. Okay, is it clear for all of you, dear students?
Yes, sir.
So up to here, what we have considered with respect to phase rule, phase equilibria, and Gibbs phase rule. So very simple topic. So read these points and practice some model questions so that you can attempt the questions very easily. So the water system, which are in equilibrium. The components are 1, phases are 3. For this equilibrium, F will be 0. That is invariable. And for the decomposition of calcium carbonate, so the components are 2, phases are 3, hence the degrees of freedom is F equal to 1, monovariant. And again, I will share this synopsis for your further study, reading. In practice, some more questions based on these points. So it's a very small topic which we are going to which we have discussed till now. Okay, anything you want to ask other than this? So if it is no more doubts, we'll stop here. We'll end this lesson session. Okay, shall I close? Okay, పంపిస్తాను PDF notes పంపిస్తాను.